This video will cover the safety features and procedural techniques for using the 14-inch large table saw. This is our large 14-inch table saw. 14-inch being the maximum diameter of saw blade that the saw will accept. It also accepts a 12-inch saw blade or saw blade smaller than that even, so long as they have the proper arbor size. It has a newer Biesmeyer T-square fence. All of our table saws in the shop have this Biesmeyer fence, which is a very nice fence system. This particular saw has a start and reset button. This is the main power. The reset is the stop. The start is obviously the start button. This also has a safety kill switch, which needs to be pulled out. Okay, so we'll pull that out. That needs to be pulled out before this machine will start. Also, if the saw happens to be locked off, if it's in the locked position, see me and I'll unlock it for you so that we can supply power to the machine. So power on, kill switch out, and then you can start the machine here. Safety features, it has a saw guard which we can raise and lower. To lower it into position, we simply lift the lever here on the arm. It's got a hose that's connected to the dust collection system to help keep the saw blade clear of dust. We typically will want that in place whenever we're ripping material. On rare occasions where you need to rip narrow material, it may be necessary to pull the saw guard up out of position so that you can make certain cuts. We'll talk about how to safely do that in a minute. We can also reposition the guard left or right up here, moving it in and out as needed, or again, in rare cases, we can move it completely out of the way for certain tasks. This fence system has a built-in scale with a hairline indicator. This is a fairly accurate scale. You can use this to accurately set your fence position. You do not need to use your tape measure. Every once in a while, it does help to check your part size after you've cut a part. If it deviates significantly, come see your instructor and we'll just verify that this is calibrated correctly. If it's not, we can adjust it. To raise and lower the saw blade, we'll use this flywheel. So counterclockwise will lower the blade, clockwise raises the blade. Full height is up about 4 inches or so. When we're ripping plywood, we only want to have the saw blade up about 1/4 of an inch higher than the thickness of our material. So if we were ripping 3/4 inch plywood, we would only want 1/4 of that saw blade sticking up above the thickness of the material. So about that high above the material. The reason being is if for some reason our fingers or our hands get close to that blade, okay, we're only losing 1/4 inch of our fingers. Any bit higher and you lose your whole finger. So we only want to keep the blade up as high as necessary to cut the thickness that we're cutting. Tilt function, we can tilt the saw blade to the right up to 45 degrees. That's accomplished with this wheel over here. And then to go back, simply spin the wheel clockwise and it will rotate to the 0 position. Anytime you're using power equipment in our shop, please remember to use your safety glasses. Some tips for ripping plywood. When I'm cutting cabinet parts, I want to be very precise in my cuts. When I'm working with full sheets of plywood, it's almost impossible to be precise when we make our first few rips and long cross cuts. So what I typically do on cabinet parts is I will oversize, or I'll rough cut all of my parts plus a ½ inch or so bigger than my finished part size. For instance, if I want a cabinet side that's exactly 24 inches wide, I would rip the first rip at 24½, just to give me that extra little bit to cut off after I've handled my full sheet and got my parts down to a manageable size. It just allows me to create a cleaner cut, having more control over a smaller part. So I'm just going to do a sample cut here, piece of 3/4 inch plywood. My saw blade is a 1/4 inch higher than the thickness of my material. I'm going to set my fence to 6 inches using the hairline indicator. And by pressing down on this ball here, that tightens my T-square fence. That fence should be parallel to the saw blade. If you don't trust that, you can actually measure to the miter slot. The miter slot is also parallel to the saw blade. And if your fence is parallel to the miter slot, then your fence is parallel as well. To turn this on, make sure your kill switch is pulled out. Press the black button. I'm going to put my saw guard back in place here. Saw guard down. If you're ripping anything narrower than you can fit your hand in between the guard and your fence, you'll want to use a push stick. Okay? Or if you're pushing something through where you can't use a saw guard for whatever reason, be sure and use a push stick to keep your hands clear of that blade. So I'll go ahead and turn it on. The thing to keep in mind when you're using any kind of table saw is you want your part to always be tight against your fence. Okay, that fence, as we said, is parallel to the blade, and so long as your part is tight against the fence, you'll generally not have any problems with kickback. Kickback is a dangerous condition in which, as you're pushing the part through, some wood, especially solid hardwoods, have a tendency to want to pull away from the fence. Okay, if your part pulls away from the fence too far, that saw blade starts to bind in the wood, and once it starts to bind, it's an accelerated process. It literally will throw your piece of wood back straight. If you're behind the blade, it will throw it back at you or anybody who's behind you. So the best way to reduce that risk of kickback is to always keep your part tight against the fence. So to keep the edge of my part tight against the fence, I prefer to stand on this side of the fence so that I can put positive pressure on my part to hold it tight against my fence. Your fence should be fairly solid, okay, just by the design of the fence. It's very rigid. I'm going to use my left hand to hold my part against the fence. So alternatively, you can use a feather board. This one happens to have a big magnet on it, so it holds itself in place fairly well. A little slap of the handle and it will pop right off. So if I wanted to use a feather board, I just set it down right there, and then that performs the same function that my left hand would in a more safe manner. I'm now ready to push my part through. When I push my part through, I like to hold the back edge with my thumb, okay, unless I've got a really long piece of material, in which case I'll kind of feed it with my right hand. But once I get down to the back end, I'll hook my thumb on the back And I'll keep my fingers toward the fence and push it through. So let's make a test cut here. I can use the kill switch to turn it off or the reset switch. Once I've turned it off, I can pull that kill switch back out. You'll notice that when I push my part through, I pushed it all the way through, and then I took my right hand all the way around. I didn't pull it back through, okay, or over the saw blade. I put it away from the saw blade. I always keep track of where my fingers are and where the saw blade is, and I always know that my fingers are clear of the saw blade. The other thing I'm not going to do is try and pull this scrap piece out until the saw blade is completely stopped. Okay, you never want to reach for a piece of scrap if that saw blade is spinning. If something's in the way, if it's got caught or fallen into the gullet of the saw, turn the blade off, turn the saw off, and then you can reach your part and fish whatever you need to out. I'm now going to demonstrate how to rip a full sheet of plywood. Ripping full sheets are a little bit more tricky in the way that you have to hold them. It may be beneficial to grab a helper to hold the other side of the board, or if you're comfortable, you can do it by yourself, and I'll show you how to do that.
I'll start by turning on the saw first, and then I'll take my sheet of plywood and I'll gently lay it down on the front edge of the table saw, being sure not to engage it into the blade yet. Set my right edge exactly up to the fence, and then go to the far corner and lift the far corner. In this case, since it's 1/4 inch plywood, I have to lift it quite a bit to get it flat on the table. And then as I feed it through, I'm concentrating to keep that right edge tight on the fence. I'll push it through and then turn the saw off. There's 2 dust gates to open for the large table saw. The first is on the upper trunk line of the dust collection system, the large diameter. The second is down towards the bottom near the planer. Be sure that both gates are in the locked open position.
We're now going to talk about how to square cut our cabinet parts, and we're going to use this jig. We call this the crosscut sled. The bottom of our sled has a steel rail that fits into our miter slot, into this miter slot here. So we're going to install this sled onto the table saw. So we're going to find the end of our steel rail, fit it into our miter slot. Okay. So we should be able to freely move our sled back and forth. Okay, you'll see that saw blade just barely kisses this edge of our sled. This stop here that I'm holding on to, this is our square edge stop. So if we put a part tight up against this wood lip, this angle, this edge here, and this cut here will create a perfectly 90-degree part angle. So this is what we'll use to make our precise cabinet part cuts. We use this for pretty much anything, small parts or large case parts, even wider than the sled itself. You can overhang your parts if they're 24, 26 inches wide. Generally, I wouldn't go any wider than about 28 to 30 inches wide, which will be rare when you're cutting cabinet parts. I'll show this example here. So on one edge I have my clean straight cut. This would be from my rip. I'll put that towards the fence, and I'm going to do this in 2 passes to cut it to length. I'm going to first make a trim cut on one end of my board, and then I'll flip it over, measure the length, and cut the other end so that I have 2 square cuts. So let's make our trim cut first. The other thing I'm going to do is raise my saw blade. You'll notice now, since I'm on top, since my sled is 3/4 of an inch thick, I need to raise my blade a bit more. Also note that I have slid my guard out of the way, primarily for video clarity. Use it if you can. Again, about 1/4 of an inch higher than your part thickness. So I'm going to let this overhang about 1/8 of an inch or so. Remember, your part length should be at least 1/2 inch bigger than your final part size. Hold it tight. So I now have one square edge. As you can see, this the end of the saw blade cut the end of my board just a hair past the end of my actual sled. When you're ready to measure your final part size, flip your board over, use the same edge that you used for your first cut, and you can simply hook your tape, and at the end of your jig, whatever the dimension of your part is, in this case I'm going to cut to 22 inches, hook your tape on the end of your part and find 22 at the end of the sled there, and that should be your part length. And then you can check that for accuracy. If you're making repetitive cuts, let's say you're making shelves that are all the same length, you may find it helpful to put clamp a stop block here so that you have multiple parts all going to the same spot if you need to make repetitive parts. So I've clamped just any stop block here so that I can slide my part up to it. Okay, and if I have many parts, I can just keep sliding my parts up. When you use the crosscut sled, we do not want to use the fence also. So you don't want to do something like this and slide the part through. What happens if we do that is this has a tendency to bind and kick back, okay? Because as it falls, it may fall crooked or sideways and get bound up and then shoot straight back. So we don't want to use the fence and the crosscut sled at the same time. As an alternative, you can use a spacer block to gauge your part position if you do want to use your fence. As long as you pull out that spacer block, you can now freely make that cut, and your fall-off piece will fall off and generally not have a problem with kicking back.